All right. Let me show the top part first. 1 through 7, see if you guys have any questions about them. Really, we're just creating the trig ratios. So we're not solving for any angle or any sides yet. Okay, but we're just going to target finding missing. We're just trying to identify the ratios. Okay. Any ones you need me to go over, or you feel okay with 1 through 7? Okay. Now 9 through
11,
okay.
13. You didn't have to draw a triangle, did you?
I think it's a lot easier to work it through having drawn the triangle, because then you know where all the pieces are. But then it looks like 1 through 5 and 7.
But it's not like required. So I think get the 5 remaining functions.
I would like to see it, just because then that's your way of showing me your work and showing me that you understand the process. Yeah, so I'll be looking for work. So yes, I do want to see that. I'll go. Let me go over number 11. I think that is potentially a tricky one because you don't see a fraction there. So okay, let me go over number 11 here. So number 11 says tangent of theta equals 3. Find use the given trig function value of acute angle theta to find the exact values of the 5 remaining trig functions. So 11 is tangent of theta is equal to 3. So we can think of that 3 as a fraction, right? It doesn't look like there's a fraction here, but really you can just treat any whole number as with a denominator of 1.
3 over 1.
3 over 1, right? And if you can see that numerator and denominator, then it's a lot easier to draw your triangle. So we know that we're going to be drawing our triangle. First quadrant. Okay, theta. And from here, we can identify which pieces we're dealing with, right? Tangent is opposite over adjacent. So that 3 will go here, and the 1 will go here, right? And then once you have that, then it looks just like 1, 3, 5, and 7. Okay. We can find the missing side using Pythagorean Theorem. A squared plus b squared equals c squared. Okay, take the square root of both sides. Technically, there's a plus or minus, but we're dealing with the physical side length of a triangle, so only square root of 10. Okay, so now we should be in the clear to find all the trig functions that we need to find, or trig ratios that we need to find. So I can say sine of theta, cosine theta, tangent theta. Okay, so sine is just going to be opposite over hypotenuse, so 3 over root 10. But every time we write down a fractional ratio, we always want to ask ourselves, is there anything that we can do to reduce the fraction, or is there anything that I can do to rationalize the denominator? So here, there's that square root of 10 in that denominator. We want to resolve that, so we multiply by the square root of 10. Okay, cosine of theta, adjacent over hypotenuse, so 1 over root 10. We can multiply. I'm sorry?
Oh, never mind.
Yeah, tangent is given, so we can write that down. But here I'm going to multiply by square root of 10. You see that there's that radical in the denominator, so I'm going to rationalize that denominator, get that radical to move up top. Tangent of theta is just 3, we know that. And now we can just flip the corresponding ratios to find cosecant, secant, and cotangent. So cosecant, I'm just going to take my original sign and flip that. It's also think of it as hypotenuse over opposite. Okay, secant is just hypotenuse over adjacent, or flip that cosine around. Or you can just write it as square root of 10, either one's fine. And then cotangent is just the flipped reciprocal of tangent, so just 1 over 3. Any questions with 11? Okay, let's just check our answer for number 13. Or 9, or if you have any questions about those. Hopefully you guys saw the link I sent you yesterday with the key, so that you're able to find and check your answers that way.
I finished and just drawing a triangle.
Okay. Any questions here? Okay, so we're going to be building off of this. We're going to be solving now a particular side or a particular angle, depending on what's missing. But we have the foundations to know, how to set up sine, how to set up cosine, how to set up tangents. Okay, so let's go to are we okay here? Okay, let's go to the next page. Okay, so now we're going to move on to finding missing side lengths of a right triangle. Okay, so this is where now we're going to be able to use either sine, cosine, or tangent to help us find a missing side length. Okay, so the first thing we're going to do is we always want to target our angle. Okay, so think of our angle as our kind of our home base, our starting point. We're looking at the rest of the triangle from that angle measure. So I want to solve for x, but I need to identify the appropriate trig function that will allow us to hit all the information to help us solve for that x. So I'm going to start off by just putting a box around that 62. Right. That's my angle measure there. And I want to be able to know what the 25 and the x are in relation to that angle. So if I'm at this location, if I'm looking out at the rest of the triangle, this 25 is the what? It's the opposite, and the x is the hypotenuse. Okay, so I'm going to just label that opposite, hypotenuse. So if we're dealing with opposite and hypotenuse, which trig function is going to help us that will hit all that information for us? Sine, cosine, or tangent? That'd be sine, right? So let's.
About the inverse of sine.
Let's talk about. We will deal with inverse when we are solving for an angle measure, but we're trying to solve for a side. We're not going to deal with inverse just yet. Okay, but let's set this up. we know that sine of theta is equal to opposite over hypotenuse. Okay, so sine of theta, my theta is 62, opposite is that 25, and the x is the hypotenuse. All right, so I can say sine of 62 equals 25 over x. Okay, any questions here? Okay. We want to solve for x. We have a way to get to it because we have an algebraic method that we can solve for x. So I'm going to create a fraction out of that sine 62. I can always put a 1 in the denominator if there's no denominator showing. So now I can solve for x by just doing cross product, right? I can pair the diagonals together. Now make sure we understand that x is outside the sine and 62. So we will say x sine 62 equals 25. Okay, so how can I get that x by itself?
Divide by sine 62.
Divide by sine 62. Okay. So you see how that everything clears off from the left side. We just have x equals, and then the rest can just go into our calculator. So in your calculator, I'll show using the scientific and then show using the graphing. Make sure, first of all, that your mode, that you are in degree mode. Degree mode. Okay. Next, we can just enter everything in. So 25 over sine of 62. I get 28.314. Same thing here. If I'm using my graphing calculator, you can go to mode. Make sure that degree is highlighted if you're using your graphing calculator. And then same thing, 25 over sine 62. $28.314.
You just leave it like that.
Yes, yeah. I prefer 3 decimal places. So I will kind of let you know because that's what's is required for on AP exam. So that's next year. So I want to kind of get into the habit of 3 decimal places, but I will confirm and yeah. So if it's a test or a quiz, I'll specify clearly what decimal place to present it in. But sometimes in your assignments, you may see 2 decimal places or 3 decimal places. So, but right now, let's just go for 3 decimal places. Okay, so as a recap, what we're doing is we are starting with the angle. Think of that as your starting location. From there, look out at the rest of the triangle, label the sides that have information on it. And then from there, you should be able to identify whether to use sine, cosine, or tangent, set up your trig equation, and then look to do cross product and solve for x. Okay, that's if we're trying to find a missing side. Okay, any questions? All right, so I'm gonna have you guys try number 2. See how you guys do.
Would it be a negative?
These all should be positive now. They should all be positive. Okay. Okay, so make sure that this 8 doesn't. That 8 there, that 8. You can't touch that 39. That 39 is inside the straight line. So that's what you can do. It'll be off there. 8 times 39. Yeah, that's it. Yeah, just enter it in the calculator. Yeah, go ahead. So you can just type in 8 and 22. So there's a hidden parentheses here, so it's probably. So.
I got you, man.
Good, that's right.
Can I just keep going?
Yeah, well, hold off on 3 because 3 is a little bit different. 3 or 4. You can try, but this is all reviewed from last year. But, just know that 3 and 4 can be a little different. It does involve numbers, so.
Then I'll wait.
Good. So, we want to do sine, right? So I only want to label. Okay, so you see how we don't have anything for components. There's no label here, so we're only going to use opposite images. So let's try that. Sine, cosine. Oh, you said it's also like this. And what's there? Okay, so we're targeting that 39. We see the x and 8 are defined, so we'll let x be opposite. 8 is the adjacent, so we'll say tangent of 39 is equal to x over 8. Okay, we put that over 1. Cross product. So now we're left with x equals 8 tan 39. Okay, the rest goes in our calculator. Make sure, though, that the 8 and 39 don't get mixed, right? We can't do 8 times 39. That 39 is inside the tangent. It's in a different location than 8, so we can't do 8 times 39. We have to do 8 times tangent 39. So if it helps, you may want to always put a parentheses around the trig function as a reminder that they are connected, and not only that, tangent, that 39 is inside that tangent. Tangent is not a standalone. Okay, so 8 tan 39, we solve for x, we get 6.478. Do you guys get that as well? Okay. So number 1 and 2 are examples of finding a missing side of a right triangle. Okay. Now 3 and 4 is a little bit different because now we're trying to target a missing angle. Okay. So we're trying to target a missing angle. We're still going to set up the same way. We're still going to set up our trig equation, identify whether we want to use sine, cosine, or tangent. But then the next step is going to be a little bit different because we're finding a missing angle and not a missing side. Okay, but you're going to see that this setup is going to feel initially the same. Okay, so I'm going to put a box around that theta. That's going to be our starting location. And we're going to look out at the rest of the triangle. Okay. Now, the 12 is what? Adjacent. Okay. And the 16 is hypotenuse. Okay. We only want to put labels on the sides that actually have information. Okay. If you also label this side, then it makes it more difficult for you to identify which trig function to narrow down to. So we only want to target the adjacent and hypotenuse. So which trig function are we going to use? Sine, cosine, or tangent? Cosine, right? Cosine. Okay, so we're going to set up cosine. But notice how here, notice that the variable that we're trying to solve for is not located on the right side. The variable we're trying to solve for is inside that cosine, which means that there's a different method when solving for an angle. So we have to use something called inverse. So let me show you what that's going to look like. We have to get that cosine, that theta by itself. The way we can undo this cosine on the left side is we're going to take the inverse cosine of both sides. So you see how this cleans up inverse cosine and cosine. These are inverse functions. They're just going to kind of wipe each other out. So we're just left with theta is equal to inverse cosine of 12 over 16. So we have to involve inverse whenever we're trying to find a missing angle. So in your calculator, let me show on the 36 Pro first. You're going to hit cosine, but you're going to hit that twice because if you hit it twice, it's going to take you to inverse cosine. And then just type in 12 over 16. Okay, 41.409. Yes. That's fine. That's fine. This depends on where you round it. Yeah, but 410 is fine.
And then you do the degrees.
That's right. You do the degree symbol because we're dealing with degrees, right? Okay. Now, if you're on your graphing calculator, if you're trying to hit that inverse cosine, you're going to go to second cosine. Second cosine will hit that inverse cosine. Okay. Yeah. Okay, any questions there? Okay, so can you guys try number 4? See if you can set up your equation. It can be very similar to number 3. Okay, very similar to number 3.
The same for 5 and 6.
Yes.
It doesn't sound.
So now
Are you just doing the 90 degrees?
Yeah, let me go over that. Let me go over that. Hold on, wait for me on that. Okay, now cosine is going to be adjacent hypotenuse, so it's going to be able to.
I have a question. Say check X over 5.
Okay, let's check number 4. You guys got 55.150 degrees. I just got that 0 and I put 55.15. Okay, now let's look at number 5 here. Now we're going to be putting together knowledge that we gained from solving missing sides and also solving missing angles. Okay. Now, when we're trying to solve a triangle, that means we're going to identify all the missing side lengths and all the missing angle measures. Okay. We're also going to use different knowledge that we have about right triangle to help us find other information. So keep in mind that angles inside a triangle totals to be 180 degrees. So if I have 2 angles known of a right triangle, I can always find that third missing angle by involving, subtracting from 180. Okay. And then the other one is Pythagorean Theorem, a squared plus b squared equals c squared, can help to find a missing side if we have 2 sides known for a right triangle. Okay. Okay, thank you. Okay, so let's look at number 5 here. Number 5, notice that if I'm asking for you to find a missing side length, all side lengths and angle measures, that means eventually we're going to need to find angle B, we're going to find angle A, and we also need to eventually find side length AC. Okay, but let's start with the easiest thing first, right? Here, if I'm just looking to see what's the easiest thing for me to find, I don't even have to involve any trig. I can just think, well, I have a missing side. I have two known sides. I can do Pythagorean theorem, right? A squared plus b squared equals c squared. So I'm going to do exactly that. I'll call this x, and I'll say 7 squared plus x squared equals 11 squared. Okay, so I'm just targeting the easiest thing I can find first, and then I'll deal with the angles in this case later. Okay. Okay, so 121 minus 49, 72, yeah. We can take the square root of both sides.
6 squared.
Good, yeah. So if you have a calculator or if you have a 36 Pro, it'll do that for you. But you can also think of 72 has a perfect square of 36. We can take that 36 down to 6. So therefore, x equals 6 root 2. So now we have to find missing angles. So if you look, we can't just subtract from 180 and find the missing angles because there's 2 missing angles, right? So we got to involve inverse, or we got to involve trig. Now here's the thing: is that there's a lot of options. Okay, you can decide whether to start at angle A. You can decide whether to start at angle B. You can use any trig function. You can use sine, cosine, or tangent. There's almost too many options available to you, so you really need to decide which one you want to use and stick with it. Okay, so I'm just going to arbitrarily choose angle B. Okay, and there's too many sides, right? I have everything available to me, so I'm not restricted to just either sine, cosine, or tangent. But I'm going to just rely on the original information, just because in case I made a mistake here, I can still rely on the original values to help me ensure that I'm getting the right answer. So, but anything is fine. I'm just going to target cosine, though. I'm going to say cosine of B is equal to 7 over 11, and that will help me locate this angle measure. Now this is, you notice that the angle, the variable that we're looking for is an angle measure. We can't cross multiply. We got to involve inverse cosine. So I'll take the inverse of both sides. And the rest can go in our calculator. $50.479 degrees. Okay, so I have angle B identified. But I can find angle A a lot easier now. I don't have to go through trig anymore because we have an easier path. You know that all 3 angles add up to be 180. You know that I got 2 angles, I can find that 3rd angle. Okay, but I want to show you a different shortcut here. Is we don't necessarily have to involve 180 because you know that angle C is 90 degrees, right? Which means that angle A and B must add up to also be 90 degrees, right? Because 90 plus 90 equals 180. So let's just do this. We know that angle A and B must add up to be 90 degrees. So if I know that, then I can do 90 minus 50.47, and that will take me to angle A. Okay, but say it again.
39.5.
That's right, 39.52. 0.521, yeah. But if you want to just always involve 180, that's fine as well. I just figured that, you know, if we can just do a quick calculation involving 90 and this angle measure, we can always get to that complementary angle. Okay, number 6. Let's start with the easy stuff. Well, first off, any questions with 5? Okay, so number 6, we'll start with the easy things here. I think the easy thing is, well, finding missing sides using Pythagorean Theorem is not going to be easy to do, right? We have too many missing pieces. But will it be easy for me to find the missing angle here? Yeah, just subtract from 90, right? I know that if I have 2 angles inside a right triangle, I can always just subtract and get that missing angle. I know that 37 and this angle must add up to be 90 degrees. So I just do 90 minus 37 to get that angle measure there. Actually, you know what? Let me hold off on that because that may throw students off in terms of solving for x. So yeah, but I'm going to hold off on that information right now. I'm just going to go and solve for x because at least I have just enough information so that I'm not having to decide between a bunch of trig functions, okay? So I'm going to put a box around that 37. I'm going to solve for x. Okay, which trig function do you think will be the best suited for what's available? Sine, right? X is opposite, 42 is hypotenuse, will involve sine. So sine is opposite over hypotenuse, so I can say x over 42. Okay, we can do cross product. So I can say x equals, make sure you don't do 42 times 37, it's 42 times sine of 37. Okay.
I don't know if that's right. Oh, it's great.
What'd you get?
I'm saying for the last missing angle.
Okay, okay. I'll get to that.
I was talking
I got x equals 25.276.
Yeah, I got that.
Oh, I use whiteout.
Like what?
Okay, 25.276. So now, once you use trig once, then you can just rely on triangle properties, right? I can find this angle by subtracting from 90 degrees. So measure of angle E, which is going to be 90 minus 37. And then how can I find this missing side? I know what x is, so if I have 2 sides of a right triangle, I can find the third missing side by using what? Pythagorean theorem. Okay, I'll call this y here, and I'll just go through a squared plus b squared equals, or x squared plus y squared equals z squared. Sorry, I wasn't consistent here. 276. Okay, any questions with this? Okay. I'm going to assign, well, homework is going to come from the following pages 8 and 9.
Oh, the code.
Yeah, page 8 and 9. Just the odds. We're going to skip the word problems. I'll write it down in a second, and I'll also send you a text remind so that you know exactly which problems.
So just the odds and skip the word.
That's right. Just the odds, skip the word problems.
Evens.
That's fine because those will be future assignments. So your effort won't be wasted. Guys, tomorrow we're going to focus our attention on word problems. But really, you're just going to set up your right triangle the same way and just have to be able to interpret word problems into a right triangle. Also, on Friday, we're going to have a quiz. But the quiz will only be 2 questions. It'll be one of this and one of this. I'm just going to change the numbers around, but basically it's 5 and 6 with different numbers.
All right.
Okay. But it won't be at the beginning of class. We'll probably spend 5-10 minutes just doing one of each. Make sure you guys are all good, and then you guys will take the quiz. Okay. Make sure that you bring your calculator. Start bringing your calculator tomorrow so that you can practice with everything. Okay.
I'm so wait, sorry. Wait, are you doing the odds or we skip the odds?
Let me write this down. 7.
I'm 18. Like I was like, well, I'm like shoulder. I'm shoulder.
Okay, hold on.
Yeah, I didn't know how to do it.